This video covers the shared responsibility model. Security and compliance are shared responsibilities between AWS and customers. AWS operates, manages, and controls security of the cloud. This responsibility includes securing components from the host operating system and virtualization layer down to the physical security of the facilities where the service operates. AWS is responsible for protecting the global infrastructure that runs all the services that are offered in the AWS cloud. The infrastructure is composed of the hardware, software, networking, and facilities that run AWS cloud services. You assume responsibility and management in the cloud. The security steps that you must take depend on the services that you use and the complexity of your system. Customer responsibilities include selecting and securing operating systems that run on EC2 instances and securing the applications that are launched on AWS resources. Customers must also select and handle security group configurations, firewall configurations, network configurations, and secure account management. Customers are also responsible for managing their data, including encryption options. Consider an example where your company uses Amazon S3 to store data. Your AWS environment also includes EC2 instances and an Amazon Relational Database Service, or Amazon RDS instance. These resources run a MySQL database, which is deployed inside a VPC. One EC2 instance hosts a web server, and the web application that runs on it uses a database to store application data. In this scenario, AWS is responsible for protecting the global infrastructure, which contains the physical servers that host the virtual machines and storage hardware. These virtual machines and storage hardware host your S3 bucket, EC2 instances, and database instance. AWS is responsible for the security of the physical networking infrastructure that ensures that these components can be accessed. AWS is also responsible for the security of the hypervisor layer that hosts the EC2 instances. You, the customer, are responsible for managing the guest OS that runs on the EC2 instances, including Microsoft Windows or Linux OS updates and security patches. You're also responsible for managing any application software or utilities that you install. Additionally, you are responsible for the configuration of the security groups that control network access to each EC2 instance and to the RDS database instance. Finally, you're also responsible for configuring security on the S3 bucket and the objects that you store in it. While AWS secures and maintains the cloud infrastructure, you are responsible for securing everything that you put in the cloud. Before you architect any workload, put practices in place that influence security. You want to control who can do what. In addition, you want to be able to identify security incidents, protect your systems and services, and maintain the confidentiality and integrity of data through data protection. You should have a well-defined and practiced process to respond to security incidents. These tools and techniques are important because they support objectives such as preventing financial loss or complying with regulatory obligations. When using AWS services, you maintain complete control over your content and are responsible for managing critical security requirements, including the following: the content you choose to store in AWS, the AWS services that are used with the content, the country that the content is stored in, the format and structure of the content and whether it is masked, anonymized, or encrypted, and who has access to that content and how those access rights are granted, managed, and revoked. Now let's complete an activity about the shared responsibility model. The purpose of this activity is to examine whether AWS or the customer is responsible for the security of various components in an architecture. Consider this scenario. A customer uses Amazon S3 to store data. The customer manages a VPC that contains an EC2 instance and an Oracle database instance. Pause the video for a few minutes and think about who's responsible for each item on the slide, AWS or the customer. When you're ready, continue the video and we'll review the answers. Okay, let's look at the answers. First, upgrades and patches to the operating system on the EC2 instance are a customer responsibility. Number 2, the physical security of the data center, and number 3, virtualization infrastructure are AWS responsibilities. Number 4, EC2 security group settings, and number 5, configuration of applications that run on the EC2 instance are customer responsibilities. Number 6, if the Oracle instance runs an Amazon RDS instance, AWS is responsible for Oracle upgrades or patches. But number 7, if Oracle runs on an EC2 instance, then the customer is responsible for those upgrades and patches. And finally, number 8, S3 bucket access configuration is a customer responsibility. Now consider a different architecture. This VPC has a subnet. The subnet has an EC2 instance with a web server which can retrieve objects from an S3 bucket. An internet gateway is associated with the subnet to allow communication between the web server and the internet. Users can connect to the web server through the AWS Management Console or through the AWS CLI by using an SSH key. Pause the video for a few minutes and think about who's responsible for each item on the slide, AWS or the customer. When you're ready, continue the video and we'll review the answers. Okay, let's look at the answers. Number 1, AWS is responsible to ensure that the AWS Management Console isn't hacked. Number 2, configuring the subnet, and number 3, configuring the VPC are both customer responsibilities. Number 4, protecting against network outages in AWS regions is an AWS responsibility. Number 5, the customer must secure the SSH keys. Number 6, ensuring network isolation between AWS customers' data. And number 7, ensuring a low latency network connection between the web servers and the S3 bucket are AWS responsibilities. And finally, the customer is responsible for number 8, enforcing multi-factor authentication for all users' logins. One approach to implement security and governance is to create a centralized team that is responsible for establishing reputable processes. This team also creates templates to deploy applications to AWS while maintaining organizational control over deployments. Such a team could be either internal or external and is referred to as a provisioning team or managed services organization, also known as an MSO. External vendors are commonly referred to as managed service providers or MSPs. AWS validates AWS partners under the AWS MSP program. MSOs or MSPs are typically responsible for provisioning accounts, establishing reputable processes for deployment, auditing the deployment of workload owners, and hosting shared services for security, continuous monitoring, connectivity, and authentication. MSOs essentially create the guardrails for security, data protection, and disaster recovery in the company. In the MSO model, workload owners handle the actual deployment, development, and maintenance of applications. Workload owners typically include system administrators, developers, and others who are directly responsible for one or more applications. Adding an MSO helps ensure that applications are deployed in a secure and compliant fashion through the automated implementation of organizational security requirements. Having an MSO also means that the workload owner can scope down their authorization documentation to only the configuration and installation of software that is specific to a particular application. This is because the workload owner inherits a significant portion of the security control implementation from the MSO. AWS customer MSOs often perform the following activities: account provisioning, security oversight, VPC configuration, IAM configuration, development and approval of templates, AMI creation and management, and development of a shared services VPC. Here are the key takeaways for this section of the module. The AWS Shared Responsibility model helps organizations that adopt the cloud to achieve their security and compliance goals. Customers are responsible for securing everything they put in the cloud. And finally, an MSO essentially creates the guardrails for security, data protection, and disaster recovery. Thanks for watching.
This section covers fundamental information about the AWS Identity and Access Management Service, which is known as IAM. IAM helps you securely control access to AWS resources. Use IAM to control who is authenticated and authorized to use resources. IAM is integrated into most AWS services. It provides centralized access management, meaning you can define access controls from one place in the console and they'll take effect throughout your AWS environment. You can use IAM to grant granular access to the console and to AWS service APIs by using existing identity systems. AWS supports federation from corporate systems such as Microsoft Active Directory and standards-based identity providers. IAM also supports multi-factor authentication, or MFA. Use IAM to manage authentication and authorization to your AWS resources. With authentication, you control who can use your AWS resources. With authorization, you control what resources they can use and how. Consider a banking analogy. Think of a bank that allows their customers, their users, to access their accounts online. Suppose you're a bank customer. Should any random person be able to log into your account and pay their bills with your money? No, of course not. Before the bank allows you to access your account, the bank must ensure the person accessing the account is you. The bank wants to authenticate that you are who you claim to be. They typically do this by requiring you to enter your username and password. For extra security, they might have configured MFA. Now, suppose you're successfully logged into the bank website. You're authenticated. Can you pay your bills with another customer's money? No, of course not. You don't have the authorization to access accounts that don't belong to you. However, you're authorized to access your account, and you're authorized to pay bills with your money. How does this analogy relate to IAM? You, as an AWS account owner, must secure access to your AWS account. You want whatever data you store in your account to be secure so that others can't access it. Likewise, you want to secure the application logic of anything you build on AWS so others can't modify it. IAM provides features that can help you accomplish these security objectives. You can use IAM to control access to your AWS resources. You achieve this access control by creating users, groups, and roles. You can also use policies to enforce access control. Let's take a moment to define each of these terms. An IAM user is an entity you create in AWS to represent a person or application that interacts with AWS services and resources. A user is given a set of credentials which stay with the user until a forced rotation occurs. With new AWS accounts, the root user account is the first IAM user established in an account. An IAM group is a collection of IAM users. Use groups to grant the same set of permissions to multiple users. An IAM role is similar to a user. It's an AWS identity you can attach permissions policies to in order to determine what the identity can and can't do. However, a role doesn't have long-term credentials, such as a password or access keys. Instead, when a person or application assumes a role, they get temporary security credentials for the role session. An IAM policy is a document that explicitly lists permissions. You can attach a policy to an IAM user, group, or role, or any combination of these resources. A best practice is to attach policies to groups, then assign users to these groups. A member of a group inherits the permissions attached to that group. You can also attach policies directly to a user to further customize their access. Let's look at some IAM terminology that you'll see in this course. IAM entities are the resource objects that AWS uses for authentication. These include IAM users and roles. IAM identities are the IAM resource objects used to identify and group. These include users, groups, and roles. You can attach a policy to an IAM identity. IAM resources are the users, groups, roles, policies, and identity provider objects stored in IAM. As with other AWS services, you can add, edit, and remove resources from IAM. A principal is a person or application that uses the AWS account root user, an IAM user, or an IAM role to make requests to AWS. Principals include assumed roles and federated users, external identities that don't have an AWS account. Anytime a principal attempts to use the AWS Management Console, API, or AWS CLI, a request is generated. AWS evaluates the information in the request and authorizes or denies the request. Information in a request includes the action to perform, the resource to perform it on, and the identity of the principal making the request. Environmental data is also included in the request. To connect to an AWS service, you need to use the URL of the entry point of that service, known as an endpoint. The AWS SDKs and AWS CLI use the default endpoint for each service in an AWS region. An example of an endpoint for Amazon Elastic Compute Cloud, also known as Amazon EC2, is ec2.us-east-1.amazonaws.com. This is the US East or Northern Virginia service endpoint for EC2. You can create endpoint policies and attach them to endpoints, but endpoint policies won't override or replace IAM user policy or service-specific policies. An endpoint policy is a separate policy to only control access from the endpoint to the specified service. Here are the key takeaways for this section of the module. IAM is a web service that helps you securely control access to AWS resources. Authentication deals with who is requesting access. Authorization determines what they have access to. And finally, IAM uses users, groups, roles, and policies to provide authentication and authorization to AWS resources. Thanks for watching. This section describes using IAM for authentication. An IAM role is an IAM identity that you can define a specific set of permissions for. The permissions allow a user or service to access the resource that it needs. An IAM role is similar to an IAM user in that you can attach permission policies to it. However, you don't attach the permissions to an IAM user or group. Instead, you attach the permissions to a role, and the user or the service assumes the role as needed. When a user assumes a role, the user's prior permissions are temporarily forgotten. AWS returns temporary security credentials that the user or application can then use to make programmatic requests to AWS during the session. The AWS Security Token Service, commonly referred to as AWS STS, issues the temporary security credentials. When using IAM roles, you don't need to grant long-term security credentials to each entity that requires access to a resource. In an Amazon EC2 instance, applications or AWS services can programmatically assume a role at runtime in order to perform their designated functions. The principal that assumes the role might be an IAM user, group, or role from another AWS account, including accounts you don't own. The example on this slide illustrates a situation when you might need to use temporary security credentials to provide a role for an EC2 instance. In this example, an administrator creates the getPix role in IAM. They define a policy that grants access to the Amazon Simple Storage Service, or Amazon S3, Photos bucket, and attach the policy to the role. Next, the EC2 instance assumes the getPix role. Finally, the EC2 instance is granted temporary permissions to the S3 bucket. IAM roles are commonly used by applications that run on Amazon EC2, mobile applications, and IAM users that require cross-account access. When you interact with AWS through the console, AWS CLI, or AWS SDKs, you'll need to provide credentials. Two primary types of credentials are used for authentication. The type you will use depends on how you access AWS. To authenticate from the console, you must sign in with a username and password. To authenticate programmatically through the AWS CLI, SDKs, or APIs, you must provide an AWS access key. The AWS access key is the combination of an access key ID and a secret access key. The situation will dictate the authentication method needed. In most circumstances, a human user will use the console or AWS CLI method, whereas an automated program will use the SDK or API method. You might also be required to provide additional security information. For example, AWS recommends that you use MFA to increase the security of your account. Multi-factor authentication, also called MFA, is a best practice that adds an extra layer of protection on top of your username and password. MFA requires 2 or more factors to achieve authentication. Common authentication factors are something you know, such as a password, something you have, such as a cryptographic token, and something you are, such as your fingerprint. By default, MFA is not activated in IAM. When MFA is enabled and a user signs into the console, they're prompted for their username and password, which achieves the first factor, something they know. They might then be prompted for an authentication response from their MFA device, achieving a second factor, something they have. Examples of MFA devices include security key devices such as YubiKey and Gemalto devices, and virtual devices such as Google Authenticator or Authy. In this scenario, your organization has created multiple AWS accounts to isolate your production environment from your development environment. After testing an update within the development environment, you need to grant members of the developers group temporary access to update the production app S3 bucket. This diagram displays the steps you can take to grant temporary access to members of the developers group. First, an administrator within the production account creates a role that grants the development account read-write access to the production account. To do this, the administrator defines a trust policy that specifies the development account as a principal. This will authorize users from the development account to assume the Update App role. Second, within the development account, an administrator grants members of the developers groups permissions to switch to the Update App role. Because this is a role which is temporary, the developers will be granted permissions to call AWS STS to provide a temporary security token. When this is complete, any IAM user that belongs to the developers group will be allowed to switch to the Update App role as needed. Third, the user requests to switch to the Update App role using the console, API, or AWS CLI. Upon receiving the role request, AWS STS returns temporary credentials to the requester after verification is complete. Finally, using the temporary credentials that AWS STS provided, the user from the developers group is permitted to update the production app bucket in the production account. Here are the key takeaways for this section of the module. A best practice is to attach IAM policies to IAM groups and then assign IAM users to the IAM groups. IAM roles use temporary security credentials. AWS STS provides temporary credentials for roles. And finally, MFA adds an extra layer of protection on top of your username and password. That's it for this video. Thanks for watching. This section covers additional authentication and access management services. Identity federation is a system of trust between two parties to authenticate users and convey information needed to authorize access to resources. Identity providers, or IDPs, are responsible for user authentication. Service providers, or SPs, such as services or applications, are responsible for controlling access to resources. Through administrative agreement and configuration, the SP trusts the IDP to authenticate users and grants them access to the requested resources. Two AWS services are available to provide federation to AWS accounts and applications: AWS Single Sign-On, commonly called AWS SSO, and IAM. If you are using a single centralized directory, AWS SSO is a great option to employ. If you are using multiple directories within your organization, or if you wish to use attribute-based permissions, consider IAM. With AWS Single Sign-On, or AWS SSO, you can create or connect identities once in AWS and centrally manage access across your AWS accounts. AWS SSO provides a unified administration experience to define, customize, and assign fine-grained permissions based on common job functions. Users in your AWS SSO environment can use their directory credentials to access their user portal. Users can access all their assigned AWS accounts or cloud applications. You can flexibly configure access to run parallel to or replace AWS Account Access Management by using IAM. AWS SSO supports commonly used cloud applications such as Microsoft 365 and Salesforce. The service provides application integration instructions that eliminate the need for administrators to learn the configuration nuances of each cloud application. AWS Directory Service for Microsoft Active Directory is also commonly referred to as AWS Managed Microsoft AD. AWS Managed Microsoft AD makes it possible for directory-aware workload and AWS resources to use Managed Active Directory in the AWS cloud. The service is built on Microsoft Active Directory, which eliminates the requirement to synchronize or replicate your existing Active Directory data to the cloud. With this service, you can use your existing on-premises user credentials to access cloud resources, which simplifies the process to extend your existing Active Directory to AWS. Amazon Cognito is a service that provides authentication, authorization, and user management, such as sign up, sign in, and access control for mobile and web applications. The service provides a secure identity store, which can help you to scale effectively for millions of users. Amazon Cognito supports direct sign-in through username and password, but it also supports third-party authentication through social identity providers such as Apple, Google, Facebook, and Amazon. Amazon Cognito relies on two main components to provide its services to you: user pools and identity pools. User pools are directories that provide sign-up and sign-in options for your application users. This integrates with social identity providers and supports security features such as MFA and phone verification. With identity pools, you can grant your users access to AWS services through temporary, limited privilege AWS credentials. Thanks for watching. This section describes the AWS Organizations service. AWS Organizations is an account management service you can use to create an organization. With an organization, you can consolidate multiple accounts and centrally manage them. AWS Organizations provides centralized account creation and management, as well as consolidated billing capabilities. With these features, you can manage your security, compliance, and budgetary needs more efficiently. Organizations also provides the ability to hierarchically group your accounts in organizational units called OUs and attach different access policies to each. This provides the ability to create and customize fine-grained policies which you can target to a single OU or attach to multiple OUs. You can nest OUs within other OUs up to a depth of 5 levels, which helps you to structure your hierarchy as you prefer. Another key feature of organizations is the use of service control policies, or SCPs, to specify the maximum permissions for member accounts in your organization. This helps you ensure that your accounts stay within your organization's access control guidelines. You cannot use SCPs to grant any permissions. They can only restrict access to a service, resource, or API action for any member account, user, or role that you determine. Any restrictions put in place by an SCP will remain in place even if the restricted actions are implicitly allowed elsewhere. Let's look at an example of an SCP. The effect of this policy statement is to explicitly deny the organization's leave organization action, which prevents member accounts from leaving the organization. Thanks for watching.